Well, hello everybody. We're gonna go ahead and get started. So hopefully you all know what you're here for. This is the Eagle training part 2. We're gonna go over board design based on the schematic that you should have from last time, but if you don't worry, and I will go ahead and share that with you. So to get started, again, if you have your schematic from the last session, you can go ahead and work from that. If not, I'm going to send this link in the Discord channel, so you should be able to go ahead and download it. So I'm going to go ahead and do that real quick. Okay, so moving along. Go ahead and get that downloaded and imported to Eagle, and then if you weren't here last time, just so you know, please ask questions in Discord. You can try the YouTube comments on the stream if they're enabled, but it's a lot easier for us to help you and monitor the chat in Discord, so I will encourage you to do that, and if you need the link, let me know, just to the YouTube comments or something. Okay. So now we're going to basically use our Eagle schematic to create an Eagle board. So what I've done is I've just opened Eagle to the schematic that we made last time. And what I'm going to do is I'm going to come up here in the top left and click this generate/switch to board. And then I'll get this little warning message that asks me, it says this file doesn't exist yet, do you want to make it? We do, because that's the purpose of this project. So go ahead and click yes, and you'll be greeted with something like this. So on the left here are all the parts that we added before, which will go, and then this, they're not on the board, this sort of yellow outlined area is the actual board. So we're going to be putting these on here, then routing traces in between them, but there's a couple things that we want to get set up first. So again, this is what you'll see. So one thing to note is you need to have both the files open for Eagle to work properly. If you see this banner at the top, it usually means that you've closed one or the other. You just want to close out and reopen the whole thing, otherwise it will not work properly, and it might mess up your whole file, so just avoid that. So this is a big block of text. I will send this slideshow if you want to reference back to it, but in summary, the idea for this is we want to basically, you're going to look at your schematic for the layout of parts, and then you want to group like subsystems together. So for instance, right here we have these diodes going from the power to these transistors and this chip and the ground. So we'd want to put these somewhat close together. We don't want to have the transistor on one side of the board and the LED on the other side of the board. That would just be a bad design choice, and you'll kind of get more of a feel for this as you do more boards, but just generally, if you've done your schematic well, you can kind of group the like subsystems together. So we're going to start by setting a dimension for the boards. Generally when you have an actual like application, you're going to be given like a limit to your board size because it has to fit in something usually. You think like, oh, if my phone has one, and the PCB can't be bigger than your phone for obvious reasons. For the purposes of this project, it doesn't really matter. So if you haven't really done anything like this before, I recommend going with this 4x2 inch size, which I'll show you how to set up in a minute, but that's just kind of the easiest way to go about it. But you can definitely do it in a smaller board. Means you have a little bit more work with routing, and just in general figuring out issues that arise. More space is just generally easier. So one thing to note before we get into resizing is the grid tool. So the grid tool in Eagle is this guy up here in the top left, and I talked about it a little bit last time, but if you click on it, you get a few options. So for the actual PCB, I recommend that you turn the display on. Now the size is 50 mil. We're probably going to shrink that down. If you don't know, a mil is 1/1000th of an inch. It's a lovely electrical engineering unit. And I'm actually going to change this to inches right now and not worry about what this is. So I'm going to hit OK, and you'll notice I get these nice little squares at 0.05 inches. But what this really does is if I click on anything like this resistor and I go to properties, you'll see the position is -0.6 and 2. So that means that's measured in inches relative to the origin, and that's important for, especially if you have parts that need to be a specific spacing apart. You need to make sure that you actually know what units your spacing are in, because 0.6 mil is a lot different than 0.6 inches. And that applies to like pretty much everything on your board. So now we're going to go through and resize the board, and I want to do it in inches so I can get that nice 4x2 value. So what I'm going to do is I'm just going to click on this yellow line, go over here, and you'll see it's this disgusting number that doesn't make sense. So we're going to leave the 0, but it's going to be from 0 to 4, and then these are both going to be 2. And this just sets the endpoint of each line. So you'll notice we get this sort of triangle because I now need to adjust the bottom one. So this is going to be 0, 0, 0, and then 4. And we get this nice rectangle that we're going to put all this stuff in. Again, you can make it as small as you want. Looking at this, I don't think I want to make it much smaller because that stuff looks like it's about this size, and we need to do routing. Let me hop back to my presentation. Again, oh, sorry, Ed sent a message. I'm confused. How did you get to the board? So Ed, what you're going to do is if you have the schematic open, you can click this little button right here, kind of in the top left under View and Tools, right below that menu. It's Generate/Switch to Board. And once you click that, it should bring you to this, or it will ask you if that's what you want to do. If you need more help, feel free to just ask in the Discord, and Reed or someone else should be able to help you out. Okay, perfect. Again, sorry, there's like a 20-second delay, I think, between me actually seeing and talking about questions to you being able to hear them. So if I ramble more than I need, I apologize. Anyways, so again, this is the grid tool. So for the actual placement, we're going to want something probably a little bit finer. We're just going to go with the recommendation here, a grid size of 10 mil with an alt of 1 mil. So if we so let me switch back over to here. So if I click grid, we're going to go back to mil, 10, and then an alt of 1. And so if you didn't see on the slides, the alt basically, when you hold down your alt key, lets you operate at a finer grid. You notice they disappear. When it gets really tiny, you have to zoom in to actually be able to see it. Otherwise, you just see a solid gray wall on the back, which you don't want. So now we're going to move on to actually placing components, but we're also going to talk about this tool over here, the Rat's Nest tool. So I'm just going to show you what that looks like in Eagle. So the Rat's Nest tool, basically, you have all these little yellow things in here, which are called air wires. And that's based on your schematic. It tells you, okay, so this part needs to be connected to here. This part and it just follows the yellow lines. And you can see it's this whole mess. But you can also think, if we look back at our schematic, all of these diodes are all these LEDs are connected to VCC at the same spot. But it would be equivalent if I connected the top lead of this LED to VCC and then connected that lead to here. So Rat's Nest will basically just find the shortest path for that to follow and let you do that. But you do have to be careful because sometimes the shortest path isn't the best path. That's not something we have to worry about that much here. But when you actually know like the application of your board, you have to take into consideration things like power, traces, and whatnot. So coming back here, we're just going to follow the suggested layout. So we're going to start with some of these LEDs in the dip switch. So in order to move components, it's very similar to the schematic. You just go to this move tool, then you find the origin of the component, and then you bring it over to where you want to put it. One thing to note is you'll see when I'm over here, when I have it over the edge of the board, I get these red sort of hashes. What that means is that you have an actual thing of copper or a through hole too close to the edge of something or to another component or a hole, and it means that based on the sort of rules that you've configured Eagle with, which you're just using the default one and you don't need to worry about that right now, but it essentially means that it's too close and that it might not be manufacturable and that you told Eagle to watch out for that and it's checking it for you. So I'm just going to place that right around there. And then we can see, okay, so there's going to need to be 8 LEDs that I'm going to grab. So I want to make sure there are other LEDs that I grab the right ones. Just a quick recap, in order to pan an Eagle, you use your center click on the scroll wheel and just drag. And in order to zoom in and out, you just scroll. Okay, so I'm going to put that there. Let's double check how he did this. So he just did it like that. So I guess I'll put this up here. One thing too that can be nice to do, and you don't again have to worry about it that much here, but if you really want these to be perfectly aligned properly, you can come into the properties and look at the position in the grid and align the Y values. Then I'm actually going to face these the other way, because that way the side that actually connects to here can connect properly. And this is something where I personally would usually use a bigger grid, just because I think it's easier to align things, but for the purposes of this tutorial, we're not going to worry about it too much. I'm going to check the YouTube comments real quick. It looks like we're good. Alright, so now I have my 8 diodes placed down here. I'm going to do a little bit of alignment just to try and get them kind of close to aligned right. But again, that's something that if you're properly doing it, you should do it with the position or a larger grid. And again, it doesn't really matter for the purpose of this because we're not actually going to make it. So now, once we have this is where the rat's nest tool comes in. So you see, okay, so this is just spaghetti here. Everything's crisscrossing. You're not actually going to route like that. It's not helpful. So what we're going to do is you come over here and you see this little, I don't really know what that is, 5-pointed shape, I guess, or connected dots. And I'm going to click it and you'll see, oh, wow, that's a lot neater now. So it just found the optimal way to connect these. So instead of having these grounds going all over, they can connect directly like that. Okay, so back to the presentation. So again, you can see there's a similar result. So one thing it says is please leave a large space at the top left. I'll put this with a power regulator in the next session that we're going to make. And for now, just place your input pins there, which we'll get to in a little bit. Okay, so this is what the person who made this decided to do for their layout. But if you can, you can really squish this down a lot more. Decide your constraints based on how you want to do that. I'm going to, again, use just a little bit of larger area just because it's faster that way. But you can spend a lot of time further optimizing these if you want to. So I'm just going to go through and do a few things to move some parts around, and again, just make it so that there's room for those other LEDs over here. One thing to remember to move, it's kind of weird in Eagle, use this group tool and then click, go to move. Oh, it doesn't want to let me do it. So you group, move, pick an item, then move group. So I'm just going to move that over here so there's room for the other LEDs and start placing all these items. As always, feel free to give feedback in the Discord. If I'm going too fast or too slow, let me know, because it is hard to gauge how you guys are doing. One other thing, I like to do a rat's nest after doing every few components just to try and figure out how to optimize where everything goes. Another thing to note is this isn't necessarily the best layout because you can see like the transistors down here are way far away from all the routing's really spread out from what the schematic is. Like we know that this has to connect to one of these LEDs, but it's way over here. That's just done for the purposes, this is the board that we actually use for soldering training, so it's nice for when you're learning to solder if all the components are together, but that's not necessarily the optimal way to actually design the circuit. So feel free to play around with that some. So I am going to choose to put them over here, and we'll see if that works out. Another thing to note, when you set this, it isn't final. We're actually going to route all the traces that connect these a little bit later, and oftentimes in that process you will change where components are on the board as you figure out, okay, this is a better design, this is a better design for different reasons. So another thing you can do that we will not be doing for this board, but it's good to know, is components don't just have to go on the top of the board. Especially service mount components, they only need one side of the board. So if I wanted to, if I center click, this puts this part, the blue means it's on the bottom, and I could put a resistor over it on the top, like that. Now we don't want to do that for these purposes. I recommend just sticking to the top, but it's good to know how to do. It also looks like the battery part that I chose is a lot bigger than theirs, so just keep that in mind. It doesn't really matter, but if you need some more room for that, do not worry about it. So one thing too, this capacitor on this package, you want to put pretty close to these pins on the actual package. Just functionally as a circuit, it'll work better if it's closer. And that's one thing we're referencing back to your schematic can be good, so I can see, okay, so this connects to here, but I want it to actually be pretty close to my power and ground connections, so I am going to put it right here where I can do that. And then I see after doing a rat's nest that, oh, it might be a little more efficient if I rotate it and put it here. So I'm going to do that. And then next, I'm just going to bring in all my resistors. So I'm just lining each of these up vertically with each other and then horizontally with this part. One thing to note, you'll see like here there's overlap between this R1 and 10K. So these are actually printed onto the surface of the circuit board, but it's just text, like it's just ink, so it doesn't really matter if they do that. If it optimizes your layout further, it's definitely worthwhile to do that. Just know that it may be harder for somebody who has seen your board for the first time to figure out what they do without the schematic. And again, frequent rat's nests can help you optimize your layout, so I highly encourage you to do that. So one thing here too that can be tough, you can see I just kind of put this R12 here because it looks like it's connecting straight to this R3 over here. But what I didn't notice was that this is actually, this air wire is coming from A1, not this net 3. So what you can do here, just look at the part to see where the net is. They're nicely labeled, and I can say, oh, well, this actually needs to be facing the other way. So I'm going to click it. Going to try to click it. I'm going to click it, then it does not want me to rotate it. Okay, click it, right click twice to rotate it all the way around, and now you can see it's coming out the right side, so it'll be nice and neat. Again, if there's any questions, feel free to ask. A lot of this is just doing very similar things over and over, but that's kind of the nature of the project. So one useful thing I can do is I can say, oh, well, this needs to be connected to the C in trace. It can connect here, but I want to see if maybe there's somewhere better to put it. So I can type show and then the name of the net. So show C in. And it should highlight everything. You can see this and this are highlighted with that name. I can see, okay, well, that really is the only one that's like that. So it can be put. If I go to the move tool, right here. And it just occurred to me, I know Angela wanted attendance taken last time. I believe there's a link in the video description, so if you all have a free second, if you could go ahead and fill that out. It's just the tiny URL at the bottom of the stream. That'd be really appreciated. Thank you. Anyways, so now we have something that it looks like we can do some routing work on. To a rat's nest. In the meantime, I'm assuming that you all might have a little bit of catching up to do, so I'm going to take a couple minutes, drink some water, and let me know if there's any questions, and then we'll keep going. If you're done and you're all done, we can move on. Just shoot a message. But again, sorry, it's kind of hard for me to figure out how far along you all are. I'll unmute myself or undeafen myself in the Discord if there's any questions. Okay, well, hopefully you've all had a chance to get something that you can at least start on. I'm going to go ahead and move on. If you haven't gotten here, don't worry about it. For the next steps, you'll be able to do pretty much everything independent of us, or of you being finished with this. It's just more tools to use with an Eagle. So as long as you have a few parts down, you can get started and catch up as needed. So the next thing we're going to do is we're going to start by adding what's called a ground plane. If you're not familiar, basically we're going to tell Eagle to put a big pad of copper everywhere on the board that it can fit it, and that make ground connections there. This is especially good in circuits that have a lot of signals, because it can help reduce noise. So we're going to do that using the Polygon Tool, which is this little pentagon here. And then we'll set some other tools that I'll walk you through. So going back to our board, we're going to select this Polygon Tool. Then we're going to set it to right angle. So there's a width parameter. This again will be in the units of your grid. I don't think that there's a suggested one for this project. Yep, we should be able to do 6. For these, I do recommend making your grid a little bit bigger, because you do have to do some alignment. So I'm just going to do 100 mil. because I think that makes it easier, but you don't have to. And I'm just going to start outside the actual board. Going to come down, come over, and I'm just boxing in the whole board. And then you have to make sure that these end on the same spot over here. This is why it's important to actually change the grid, or just be careful with it. Changing the grid just makes it easier to align. And I'm going to name it GND, in all caps. So now we have this box, and if I run a rat's nest, you'll see that it fills in everything, but everything with a ground connection gets connected like this. These little cutouts and the connections are called thermals. And the issue is that when you're soldering components like this, you have to heat up the pad. But if you have this whole massive area of copper that's your ground plane, and you try to solder or heat this up, it's going to be heating up this whole area, so it's very difficult to solder. So this only shows up when you do a rat's nest, and to make it disappear, you have to click on the outer edge of the polygon, which can be kind of difficult with this rip up tool over here. But I just generally kind of spam click around outside the board, and it works out. And I don't recommend routing with that on because it makes it really hard to see everything. Okay. So then, yeah, he's walking you through the rat's nest. So the other thing you can do instead of just clicking on it is you can do rip up at GND. Ed, you are trying to place down the polygon, but it is not letting you place anything. I don't know what could cause that. Could you maybe hop in one of the breakout rooms and Reed could help you? And you can actually stream your issue to him. I think that's probably the best way to go about it. If you're still having issues, let me know otherwise. And I'll mention that in the Discord real quick. Okay, just resolving something in the Discord, so we will come back here. So again, these are two other ways to do the rip up. This is probably easier because you don't have to click around for the trace. So now what we're going to do is we're going to add a ground plane on the bottom. And this is just helpful so that when you do two-layer boards, anywhere that one plane can't reach, the other usually can. So what I'm going to do is, again, go to the Polygon Tool, select bottom, which is number 16. You'll see it's this blue color. And I'm going to do the exact same thing. I'm going to come down here, come up, over, back, and name it GND. Alright, so following this, we're actually going to be routing different traces. So if you think about your trace, it's like a wire, it's just a flat wire. So based on the width of the trace, it affects the amount of current that it can handle. Some traces can handle, a wider trace, maybe for your power line, can handle a lot more current than a narrower trace that you might use for a signal line. So you can see here, they talk about, there's a trace width calculator that you can use. We don't really need to use it for this project. Generally, if you can do like 10 mil minimum, that's nice. For signals, but the minimum that you can really do is 6. After that, it gets difficult to manufacture and you might have to pay more to do it, which you probably don't want to do. But other higher current wires, it's nice to either use a polygon or a much wider trace. So we are going to start routing, and I will just walk you through some different things to do. Okay. So we're going to start by just connecting some of these resistors because they're pretty easy and we can do it on the top layer. So A couple things to note, service mount components. The trace has to be connected in the layer that they're on to begin with. So all these are red, so they're on the top, so we have to connect them on the top layer. But through-hole components, where you see these green marks and there's holes, you can connect on either layer because it's an actual hole that goes all the way through the board. So I'm going to start out with these resistors and then show you some things you can do with the through holes. So what we're going to do is I'm going to pick 10 mil. That's your width up here. That's how you set it. And then make sure you're in the top layer. And then I'm just going to click here, route it over. Oh, this is one thing. You do want a smaller grid for this. The grid size here affects where you can actually do bends. So you'll see right now I can only do it on these areas. But I might want a finer resolution. So that's where I'm going to use 10 mil. So I'm going to come over here, connect like that. And then I'm just going to do that for each of these resistors, and we'll move on to something else next. If your resistors are in a similar spot, hopefully you'll have something that works out nicely like that. Okay. So here we see that this is ground. Oh, sorry, I thought there was another message in the Discord. So these are all going to get connected just to the ground plane. So we're not going to have to worry about that. But these B0 lines over here actually need to get connected to the right side of these dip switches. Oh, okay. Sorry, I thought I heard something. So what we're going to do, one other thing to note for traces, actually a couple tips that I'll go over. You don't want to have it on this right angle setting like we did for the polygon. You generally want it like this. So the issue is that if you have a right angle trace, when they actually fabricate PCBs, they use basically acid to eat away parts of the copper. And if you have a right angle, it can actually, like that, it can actually cause an acid buildup that will deteriorate the quality of your trace. You don't want to do that. It's much better to do something like that, where you just have the slight acute angle. Another thing to note, one second, sorry, I had to do something on another screen. One other thing to note is that, I apologize, I lost my train of thought. When you're crossing traces on opposite sides of the board, you want them to be perpendicular. So I'm just going to do a quick example, and I'll talk a little bit more about actually routing on the other side of the board in a second, so don't worry about what I'm going to do here. So if I have this trace coming here, it's blue, so it's on the bottom. I want it to cross like this. I don't want it to say come down and run parallel to this trace like that. And the reason for that is, if you think about this, it's two layers of a conductor separated by a dielectric, your insulator. That you made a capacitor here, which can cause all sorts of issues. So it's much better if we need to do something like that to bring this trace, say, down here and then run it parallel. And again, don't worry about getting to the bottom of the board. We'll get to that in a minute. But just a couple notes to remember. So now we need to actually connect each of these to the other side of the dip switch, which will require some interesting routing. You'll notice that Eagle intentionally avoids this area. So that is basically, again, a feature of the rules in Eagle. It basically says that this cannot be more than so close to this other item. A general good rule for just signal traces is you want about 10 mil between them. For like things like power and ground, you want more because they can tend to try to jump across, so you'd want more isolation, especially in higher voltage applications. But again, you probably don't need to worry about that for now. So what I'm going to do is just route this up here and along like that, and we should be able to do something similar for each of these. And I'm just going to go along and do that for all of these. And you don't have to route these like this. I'm just picking a convenient way to do it. You can decide to do it however you want. So now one thing you'll notice here is, well, I have all these connections running in between all the dip switch connections that are making VCC an issue. So how am I going to connect this without being able to cross under each of these? So this is where we'd use the bottom layer. Because these are through hole, it's very easy to just go right under all of them. So since this is VCC, and I know it's going to be taking a bit more power because it's our power supply, I'm going to decide to change the width to 50 mil. You'll see that's a lot wider. Now this is probably excessive for this, but for the purposes of this demonstration, I'm just going to go ahead and do that. Another thing to note is that it's sometimes good to just chain things along like this to each pad that it's connected to instead of going over here. Sometimes Eagle doesn't recognize if I were to say go from 12 to 14 here, that it's connected to 13, and you'll get an error later on. So it's just a good way to do it. And ta-da! So that's all connected. And you'll see that this is nice and perpendicular here, so we shouldn't have to worry about it too much. Okay, so we're going to come back to the top. I'm going to switch back to my 10 mil traces for now. So one thing, now that I've done a little bit of routing, I might think maybe there's a more efficient way to connect some of these. So I'm going to do a quick rat's nest. And then I'm going to loop up ground just so I can see what there is. And that, again, should reroute some of these air wires to be a little bit more efficient. Okay, so let's decide what we want to do next. I think the LEDs would be nice to do. So I'm going to go ahead and do those. Another thing to note is you can see I'm toggling between these two options. If you want Eagle to, it's not quite a rotate, but change the way that it's doing, change the direction or path that it's kind of taking, you can right click and it'll try to sort of rotate it around and try another path. Okay, so Ed says in Discord, I tried using a rat's nest and my entire board turned red. So what that is it's the ground plane that you made earlier filling in. That's actually what it's supposed to do. It's just saying that it's putting that ground trace everywhere. So if you want to get rid of that, you can type the command rip up at ground, which I'll send in the Discord. Oh, looks like Reed sent it as well. And that should get rid of it. And that'll, you do want to have that at the end so you can see how your plane is behaving, but it can be difficult to start out. Okay, so now I need to actually get to these LEDs on the right. So in order to do that, I am going to want to use the bottom layer again, just so I don't have to deal with these other connections. So here I need to be a little bit careful because I do want to be perpendicular when I cross this. So cross this trace here, so I'm going to come up before I try to go over. Then I'll come up along here and over. I want to tell it to come over a little bit more, so I'm going to click there. Okay. So this is bad because I did a right angle. So I'm just going to go ahead and undo that, and I'm going to try and start that over and do a better job with it. There we go. And then I will do something similar for the other paths. And again, I did something bad here because this A1 isn't perpendicular, so I'm going to reroute it to be. So this is where you sometimes have to get a little bit clever. I'm just going to do a little cross right there before coming over again, and then reroute it. And then again, equal doesn't want to cooperate, so sometimes you have to help it out a little bit. Do something like that. Here, luckily, we can just avoid doing it to begin with, and ta-da, that's all done. Now you'll notice we don't have to route the other side of the LEDs because they're already connected to ground, and that'll be done for us by the ground plane, which is rather convenient. Okay, so next, I think, let's see. I'm going to do some of the IC connections. So this is what's called an IC if you're not familiar. That's an integrated circuit. So we're going to do some of the connections here. So a lot of this is going to have to be done on the top layer because this is a service mount component that's on the top. So just going to go ahead and connect that like that. I'm going to increase the trace width there to 20 or so, but there's not much point in going beyond that because the width of the pad is about that size. Again, so I want to come straight out and then down and over. From that pad, go and do that. So I don't like when Eagle does this sort of thing. It usually has to do with just your grid size. So I'm going to try using the alt grid to get me a little bit more resolution for where it's routing, and do that. And you see it works a little nicer. So again, the alt grid, if you're having something like that where it makes your trace bend when you don't think you should need to, if your alt grid in the grid setting here is set to something smaller than this grid, you can hold down alt and it'll give you a finer resolution, but it might be a little harder to line things up. Go ahead and make this connection. All right, so now comes the question, well, let's see, I have net 6 here that needs to connect to, did I misfollow that? Oh, yes, I did. So I have net 4 here, we'll start with, that needs to get over to here. So how am I going to do that with this trace in the way? So the short answer is we are going to weave traces through multiple sides of the board. And how you do that is with what's called a via. So we're going to start with just on the top layer, and I'm going to click this, and I'm going to come this way. So what I'm going to do now is center click with my scroll wheel, and you'll get this green circle that pops up, and that's what's called a via. So if I left click, that'll place it, and then it'll switch me to the bottom layer. And I'm going to go back because this net is too thick for what we need and change it to 10 just so we have more space. But again, come over, center click, place the via, and then I'm going to come out between these pins, then cross this perpendicular and come all the way over to here. So now, since this is a service mount component, once I'm over here, I'm just going to go back to the top because it's service mounted on the top of the board, and run it like that. So I'll walk you through a few more of those just in case you're having any trouble. So net 6, excuse me, has the same issue. So I'm going to come over here, center click, place the via, route it perpendicular, left click, come over here, center click again. So this is an interesting one actually. It has to cross back over net 4. So I'm actually going to center click again to detoggle that via. Now that we've crossed this, I'm going to come over here, come down a little bit, cross that, make sure it's perpendicular, and then I'm just going to come all the way over here on the, actually I'll do it on the top. Go ahead and do that. And we're going to do something similar. Yeah, I'm sure there's a better way I could route this. This is where you can kind of think about things for a while, but I'm just going to do whatever comes to my mind first for each of these. So here, come over, I'm going to center click, place a via, come out. I'm going to be perpendicular to cross that, and come here, make a via, place it. Oh, that was a little bit too soon, so I'm going to undo. Another thing, make sure you're on the layer at the top left. You want to be on the layer that you selected to actually start. Otherwise, sometimes it can confuse Eagle. So I will come up here. Then via back. Come in. So you can see as you get farther along, each of these gets a little bit harder to do because you have more traces that you have to go through. So for this one, I can see I have to come down over here. So I'm going to stay on the top layer until I cross this, then switch to the bottom. Come across this perpendicular, come back to the top, come down like that. Similar thing here. So this actually has to come all the way down there. So I'm going to wait on that one because I think it's a little bit easier to do later. And again, you know, your board doesn't have to match mine at all. There's a lot of different routing options that'll work just fine. And just kind of make your way through. Again, that one has to go kind of far, so I'm going to wait on it. So does C out. Just trying to do these resistors right now. Okay, so this one. So this is where it can get a little bit tricky. This is where having more space on the board can help you out a whole lot. Okay, so now that I've shown you how to do some of these are kind of the major concepts. I'm going to go back to the presentation, cover the rest of the material, and then we'll just kind of work with you guys to do it. I don't think you need to watch me route the entire board. I can sit here and do that, but I don't think that's necessary. I think you should have most of the tools that you need for that to work. So we talked about, again, when you have signals on either side of the board that cross over each other, just try and make them perpendicular. And then once you're done, if you run a rat's nest, it'll tell you that it should be all done and good to go. So this is the layout that the maker of this board went with. Obviously, mine is somewhat different, and yours can be too. So then one thing that we will do, this is good to do at the end, but I'll walk you through it again just so you can move along and work on yours, is so we have those two ground planes on either side of the board, but they're not connected by anything at the moment. So what we can do is you can actually just use this tool on the left called Via to create vias wherever you want. I can go ahead and say, okay, well, there's some good room up here. I think it'd be good to tie it together here. And then I can just place that. And then what I'll have to do is come into properties and name it GND. Otherwise it won't actually be connected. You'll get this warning asking you if you want to connect it. Hit OK. It might do a rat's nest for you, and then I usually think it's easiest to just copy and paste these, and you can kind of just sporadically place them. You just want it done so that everywhere that is connected to ground will be interleaved. So for instance, like this looks like kind of a dicey connection here, so what I'm actually going to do is put one in each of these little gaps so that the better connected ground plane on the bottom layer can connect to it. And again, that's just specific to my design. So you can place these all over, just make sure they're all named ground, otherwise they won't do anything. And you'll actually be able to see, like if I place a random via here and don't name it ground and I do a rat's nest, it'll isolate around it. So again, that's probably easiest to do more towards the end, but good to keep in mind and important to do so that your ground planes are actually connected everywhere. Because otherwise you can end up with like stray capacitance between certain ground connections and whatnot, which is bad for your design. So the last thing that you want to do is run the DRC. So the DRC is a rule checking program. It basically makes sure that there aren't any violations in your design. And you always want to do that at the end of your sort of design process. So you'd run a rat's nest before then, so I'll go ahead and run one. And then what you can do is there is a tool for it. I usually just type DRC and click enter. So there's different design rules that you can use. These are just the Eagle default ones. Okay, so Ed asked a question in the Discord real quick that I'll respond to before going on about the DRC. So if I want to change a via name, I take my via, place it here. Then I can right click on the via, go to properties, and then in the name it GND. And then you can hit OK, and you should be good to go. So jumping back to the DRC. So once you do that, you can come in here. It'll have this window. Like I said, ECE 477, Senior Design, has their own set of rules that we usually use with the team because that's more specific to some of the realistic design constraints we have. It's a little bit stricter, so you get better issue resolving. So if I run check, okay, so we're going to see there's 20 errors that are error wires. And it's going to tell me, okay, I have an error wire here. And obviously that's right, and I don't want to have that because that's a trace that I never routed. And then this board wouldn't work because of that trace issue. So once you run this, there are other sorts of errors you can have, like clearance. It'll tell you that parts are too close together. But generally you need to resolve all these first and then you can move along. So what you can do is say you have a clearance issue, but it's a part that you know will be fine. Ed, I will answer your question in just a moment. You can do what's called approve. So say I'm not going to do it because all these are actual errors, but I could click approve and then it wouldn't actually throw an error for that. So Ed, you said it won't let you right click for some reason, so you have to be really careful to kind of center it on the part. If it's not giving you an issue, it can be kind of tough for the ground plane. So I'm going to go ahead and rip that up. And then I can come in here with the name tool. Sometimes that'll work better and it'll let you do it. One thing, sometimes you can't right click because you're in a certain tool. Like if I'm in route, oh, maybe I will. Well, I've had issues before where some of the tools don't, so sometimes just switching to move, or even you can go to this eye or the info tool, and then if you click it, you shouldn't need to right click. It should just bring up that window. Anyways, that's pretty much all of the material that we have. I don't expect that you've all finished routing because I haven't, but I think that's the majority of the helpful content that I have for you. So feel free to continue along routing. I'm going to go ahead and stop the stream and just switch over to Discord and see if people need any help there. And you can ask any questions over there. Otherwise, I hope this was helpful. And again, if you haven't filled out that attendance link, please do that. Otherwise, we're good to go. Thanks, everybody.